Okay, let's jump right into this explainer. Today, we're going to explore exactly how we can confidently deploy non-deterministic large language models out into the real world. You know, if you're building AI applications right now, you already know the incredible power these models bring to the table. But you also absolutely know that creeping anxiety of wondering what on earth they might say to your users. So today is all about evals, what they are, how to build out their architecture, and how to take an AI from a simple test script running on your local laptop all the way to deploying robust, battle-tested guardrails in a live production application. Let's get into it.
To really understand why this matters, we have to look at the consequences of shipping an unevaluated AI agent. And honestly, the fallout can be massive. You might remember the infamous late 2022 case where an Air Canada chatbot confidently completely hallucinated a non-existent bereavement policy for a grieving passenger. It was a total PR nightmare, and it highlights a really critical reality. The disadvantages of releasing an underperforming agent aren't just limited to a clunky user interface. Doing so can severely damage user trust, it can expose private data, and it can cause actual, literal financial harm. Without rigorous evaluations, you simply cannot guarantee how your system is going to behave in the wild.
So, the crucial concept we've got to wrap our heads around here is the massive paradigm shift we're facing. Traditional deterministic software. It produces predictable responses based on formal, rigid specifications. If A happens, B is the output, every single time. But LLMs, they don't have formal specs. They are inherently wonderfully and frustratingly unpredictable. Sometimes they're just factually wrong, but other times the error is much, much harder to pin down. The output might be factually right, but totally inappropriate for the given context. As developers like to joke, the facts are right, but the vibes are off. And these ambiguities make evaluating AI fundamentally different from any conventional software testing you've done before.
To tackle this, here's our roadmap for today's explainer. First, the AI Evaluation Challenge. Second, bridging the three gulfs. Third, anatomy of AI agents. Fourth, the evaluation lifecycle. Fifth, scoring and LLM as a judge. And sixth, deploying evals in production.
Starting off with Section 1, the AI Evaluation Challenge, and why traditional testing just totally fails here.
Because LLM applications function as adaptive, fluid systems rather than fixed, rigid processes, we're constantly forced to ask ourselves, how do we actually measure the quality of something so inherently unpredictable? You know, a simple unit test just isn't going to cut it when there are dozens of perfectly valid ways an AI might correctly summarize an email, and literally hundreds of subtle ways it might fail. We need systematic measurements that are both interpretable and actionable.
That brings us to Section 2, bridging the three gulfs, which gives us a really helpful vocabulary for failure.
This whole breakdown maps beautifully into three distinct areas. Think of them like massive gaps or gulfs separated by water. First up, there's the Gulf of Comprehension. This is the developer's limited human bandwidth to read massive amounts of data, meaning those weird errors and outliers just aren't obvious at scale. Second, there's the Gulf of Specification, the immense, crazy difficulty of explicitly communicating your actual intent to the AI pipeline. And finally, the Gulf of Generalization, which is where the model's behavior just varies wildly across completely different unseen real-world inputs.
To highlight just how tricky one of these gaps can be, let's look at a generalization failure. This one is tough because it proves that no matter how absolutely perfect your prompt is, the AI will still occasionally produce the completely wrong output. For instance, say you build an AI stylist app. It gives phenomenal suggestions for casual winter wear. Naturally, a user might assume it'll also perform great for, say, winter weddings. But if the AI hallucinates some terrible, inappropriate outfit for that wedding, well, that's a generalization failure. The prompt was completely fine, but the model misapplied it in a brand new context.
Moving to Section 3, anatomy of AI agents. Let's look at the building blocks of complexity.
Modern AI architectures almost always progress in complexity. You usually start out simple, right on your local laptop, maybe using a basic Python library like LLM to make a single-step LLM call. But production apps scale quickly. They evolve into continuous multi-turn conversations that require complex memory management. Then we start adding Retrieval Augmented Generation, or RAG, so the AI can search external documents. And ultimately, we end up building agents capable of autonomous tool use, where the AI is out there calling APIs or executing actual code. And here's the catch. Every single added component brings amazing new capabilities, but it also introduces entirely new ways for the system to break.
And this is exactly why evaluation is so incredibly complex.
Every single component we just talked about requires a completely different set of specific metrics to make sure it functions safely. You absolutely cannot test a RAG system the exact same way you test a basic prompt. For RAG, you've got to measure context relevancy. Basically, did it fetch the right document? For tool use, you need to measure the success rate and tool selection accuracy. Did it use the calculator, or did it try to query the database? For conversations, you're evaluating recollection accuracy over time. Different use cases demand totally different measuring sticks.
Now for Section 4, the evaluation lifecycle. We need to analyze, measure, and improve.
The core framework we relied on here is a constant iterative lifecycle. It goes like this. First, we analyze. This is qualitative. We're actually reading individual traces of user interactions to find out exactly where things are breaking down. Second, we measure. This is quantitative. We take those specific failures we found and build rule-based checks or data sets to test for them at massive scale. And finally, we improve. We tweak our prompts, we tune our RAG pipeline, and then we start the whole cycle all over again.
Anthropic has a really fascinating approach to the analyze phase. They rely on continuously reading end-to-end system traces. These traces are basically the complete step-by-step records of an AI's internal thought process, its tool calls, and its final outputs. So you read through these traces and cluster them into a taxonomy of specific failure modes. You literally have to sit down and categorize these errors until no new failure modes pop up. It's tedious, but it is the absolutely essential groundwork you have to lay before you can even think about writing automated tests.
All right, Section 5, Scoring and LLM as a Judge, and the necessity of multidimensional assessment.
So you can't just track one single metric here, because AI evaluation is a giant balancing act. A major disadvantage of optimizing for just one dimension, say trying to improve accuracy by shoving a massive context window into the model, is that you might inadvertently completely ruin your latency. Suddenly the app is agonizingly slow for the user, and your token costs are going through the roof. You need comparative evaluations. You have to track accuracy, hallucination rates, latency, and cost all at the exact same time, just to make sure that fixing one bug doesn't accidentally cause a massive regression somewhere else. To score all of these open-ended, semantic outputs at a massive scale, modern systems rely heavily on a brilliant technique called LLM as a judge. Because traditional software unit tests can't exactly parse whether a summary is genuinely helpful, we actually use a separate, independent LLM to grade the output of our primary agent. This judge model compares the agent's response against a known good answer, assigns it a score, and, this is the best part, it even provides a written explanation for why it gave that specific grade. The massive advantage here is that it gives us the ability to automate incredibly nuanced measurement at scale without totally exhausting a team of human reviewers.
Finally, Section 6, Deploying Evals in Production. Let's take all this theory and put it into action.
When it comes to real-world deployment, enterprise solutions like Oracle's AI Agent Studio give us a highly effective 5-step playbook. You absolutely must start by defining clear business goals. Then, you build a representative dataset, and that has to include your adversarial edge cases, not just the easy, happy paths. You conduct the evaluation using your automated guardrails and those LLM judges we talked about, you analyze the thresholds, and then you iterate. In a production environment, evaluation isn't just a final destination you visit right before shipping, it is a continuous, cyclical habit deeply embedded right into your CI/CD pipeline.
So, as you gear up to bring your next AI product to the market, whether it's just a simple script you've been running locally or a massive multi-agent enterprise system, I really want to leave you with this one thought to ponder. Without rigorous structured evaluations, are you shipping a robust solution or are you just shipping a brand new layer of chaos? By embracing the evaluation lifecycle, defining crystal clear metrics, and building automated scoring systems, you really can tame the non-deterministic nature of LLMs and ship with absolute confidence. Thanks so much for joining me on this explainer, and I'll catch you in the next one.